everyone. Good evening. It's 8 p.m. Thursday night, and I am Jill Wolf, and I'm coming to you live. I'm continuing my series tonight, episode 7 of Using Play to Improve Writing, and tonight we're going to look at scientist. What can we do to improve writing when we play scientist? For those who don't know me or don't know me well, I'm Jill Wolf. I'm a learning specialist, and I help homeschool parents plan meaningful experiences to awaken the learn in learning. And I'm excited tonight to look at the learning of improving writing and to look at it around playing scientist. Now, this one is near and dear to my heart because I actually got my degree in a science field, and I think that the earth and the natural world is so beautiful and so incredible and so full of not just adventure, but so many things to discover that I get excited to pass that along to young people and have them get excited. I think sometimes science gets sold as either a kind of a religion, which I'm not even going to touch tonight. I'm going to go for the real pure view of science, which is it's understanding, it's discovery, it's experimenting to discover how the physical world works. And that is really exciting to me. So, I'm talking about the way science gets sold wrong. So one is it can be seen as religious. The other is that it's for boys only. That's kind of an old school thought. I think there's a lot of programs nowadays to help girls get excited about science and get excited about the sciences. And the third way it gets undersold is I think it gets sold as it's just a body of knowledge, not a way of thinking, not the discovery action, not the action of pursuing new information about how the physical world works. So many times scientists just read an article, read the science textbook, and make sense of ideas that are already in existence. Instead of I'm experimenting and I'm observing and I'm kind of putting it together, maybe stuff that's already known, but in a way that develops a certain kind of thinking so that if I choose to go into this field, I can go to the edge of knowledge of what's known and discover new things. So I'm going to look tonight at the idea that scientist, when we play scientist, your child is probably playing I'm experimenter, I'm mixing things and exploding things, and I'm observing and looking at things, and I'm trying to make, look at the relationships between things, and I'm using props and costumes. That's the kind of science that I'm imagining you play. So first and foremost, you have to have the costume, right? So that comes with goggles, and that comes with a lab coat, which the lab coat I have is actually a kid's coat because of something I used it for. So I'm going to put it around my shoulders for now, just for the look, but because it doesn't actually fit. But the lab coat, and I have to tell you, some curriculum, and we were field testing it with some students. And so we took all the students, they were in groups, and they were doing all the steps of the test. Okay, these are fogging up, so I can't see you, so I'm going to take them off. But anyway, we took these kids, and we took them all through the exact same experience. But we took 4 of the girls. It was actually a huge group of girls. We took 4 of the girls and we gave them lab coats, these lab coats actually, to wear during the entire investigation, during the entire experience. And these girls, when you observed them as a whole group and you watched these 4 in comparison to these 4 took it so seriously. Just by putting on the costume, just by putting on the lab coat, man, they were serious scientists. So if your child enjoys playing scientists, get them a lab coat. They're not that expensive. You can buy it for 15, 20 bucks on Amazon, and they really do affect the play because they give them the feel that they're a real scientist. Costumes always affect play. So in this case, a little lab coat. Anyway, so you have the lab coat, you have goggles, you might actually have a microscope. Like this is a nice prop. I actually just got this for my husband for his birthday. he's starting a course where they're looking at, it's an agronomy turf kind of course, and they're looking at things. So I got him this so he could look at stuff at home. And he was really excited. He said, I never got to take a science in school where they let me use equipment like this. They always said I was so dumb. They put me in sciences that didn't have really expensive equipment. That's so sad. Anyway, so this is a microscope that he's going to be able to look at stuff. So play can involve just costumes, or can actually involve some investigative equipment. So that's first and foremost with scientist play. But then we get into this. What exactly is your child doing during their scientist play? Are they experimenting with things? Are they imagining that they're mixing stuff? Or do they actually ask for props and things in the kitchen to mix? Are they out there looking at plants and watching birds and writing down data? Do they see themselves? Are they self-identifying as a scientist and attempting to do science? Is that what the play is? Because if that is it, then there's this innate interest in all of us to be curious. This innate, I wonder. It starts at like 3 when they first start talking. Why is the sky blue? Why did mommy say that? Why is the door closed? Why is the dog bark? Right? Incessant questions. As they get older, they may have a few less, but they still are curious about how the physical world works. They observe something and they want to know about it. And so that is naturally there. So playing scientist actually naturally comes out of that. I think sometimes, though, as parents, that if you're not comfortable with science content, you tend to rely on either things you find online, like YouTube videos of how to build a volcano, or directions on like how to assemble a bug collection, or you buy kits, like here's a whole bunch of ingredients to make colorful slime. But I don't know that you always think, well, let me just ask them questions about things they're curious about, and from there, consider which science field they tend to be gravitating towards. And then let's look at some things in that area. So I came up with some things I want you to do as they're playing scientists, or as they're starting to show scientists. You can expand this number 1 by asking them about the experiment that they're doing in their imaginative play. So as they're doing science, say, what are you doing? What are you mixing? Well, why are you mixing those things? Now, if they're actually asking for things to mix, why are you mixing vinegar and baking soda? Where did you hear about that? Or what do you think you're going to see? Why are you looking at the blades of grass with a magnifying glass? And which is another prop. What are you doing and why are you doing it? Let them begin to explain to you some of their scientific thinking and pursuit. And some kind of writing that comes out of that is, well, let's actually document what you did and what you're finding, even if it's just in play. So I have to tell a story here. My nephew, who's now 15 and pursuing film, and I'm so proud of him, but at age like 3 and 4, he was really into dinosaurs. And so his mom, my sister, is actually a science teacher. And so she used to always talk to him about dinosaurs, and they'd read about dinosaurs and they'd talk about dinosaurs. So here he was at 3 and 4 years old, and he was using the word environment and habitat and carnivore and herbivore. And he had all of this language. He couldn't write anything. He couldn't spell anything, but he could use all this language. He was using it correctly, which is the beginning of writing, right? Talking and speaking is the beginning of writing. So I used to have conversations with him, and it was so cute. I wish I had taken pictures because I think it's priceless, but he had this little football journal that his dad had given him, and in it he had just done squiggles, 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 squiggles. Like the whole book had squiggles all over the pages. So I remember one day I flipped open his journal, and I'm like, I said, what does this page say? What does it say right there? And he goes, well, right there it says that the Stegosaurus is a carnivore. And I said, oh, and he goes, but it's wrong. A Stegosaurus isn't a carnivore. I said, well, what is it? He said, a Stegosaurus is a herbivore. And I said, well, you need to fix this. You can't leave this mistake, and you got to fix it. So I handed him his journal, I handed him a pencil, and he crossed out the squiggle and he put another squiggle above it. So here he was at 4 years old, understanding the idea of revising what I've recorded in my scientific journal. The idea that science information is revisable. that I keep a journal of information that I'm learning or experiments that I'm doing at 4. And he wasn't even able to spell or write anything. It was just fascinating. So no, regardless of their age, if they're imaginative play, if they're asking to mix and try some things, then you can begin to collect data. And you can know, what data are you collecting? Well, what are you finding? Well, where are you recording this? And it might push them into, well, I actually want to do a real experiment where I can collect real data. Great. Then you jump right into that. Part of writing in science is data tables. We sometimes think that writing, again, and I touched on this before. Hi, Karen. Sometimes we think writing is just narrative paragraphs, right? I shouldn't say narrative because that implies story, but just paragraph, paragraph, paragraph. And we forget that many times writing is the act of communicating what I understand to somebody out here. And I can do that through other kinds of visualizations, and one is the data table. In science, that is a very common way to communicate information. And so as you're doing and having your child's imagining, or they're want to try some things, have them create a data table and just, well, what data are we collecting? Well, how can we put that on this table? And that's the first step. So then another kind of question you can ask them is, well, what do they want to study? So the first the first kind of category I gave you is, what are they playing? What are they experimenting? What are they looking to, playing that they're studying? The second is, what do they want to study? So what kinds of things do you want to learn about, or that intrigue you? And so then we take those topics and we begin to look up, well, what sciences are those? So one kind of writing might be, I'm going to actually research with my child, we're going to research the kind of scientist that studies the kind of thing my child's saying they want to study. So for example, they like plants. My little guy's just 2, and my husband, being in agronomy, loves planting. They've been planting a garden. And so every day, little Jake goes out there and he touches all the leaves. And I'm like, what are you doing? Well, he doesn't talk yet, so he can't explain, but he's touching all the leaves. And I know what he's doing, exactly what John and I do, which is go out and touch the leaves to see, do they need some more water? We look to see where the new growth is. We look to see if they got a film on them, if they're smooth, if there's an oil and they smell. And so he's out there doing it just like we do it, right? So he's intrigued by plants right now. Maybe your child is intrigued by plants, and you could do a garden project, or you could study different plants, or depending on where you go, where you live, if you want to travel and look for different places, or even going to a nursery and looking at the different kinds. I mean, what you could do around plant investigation as a scientist, you'd be called a botanist. I want to study plants. And so today we're going to play botanist, and we're going to go to the nursery at Home Depot, and we're going to go look at the different plants. We're going to look at what kind of plants would grow best where we are, or what kind of plants. I mean, you can, all sorts of things. If they are curious and interested in studying plants, then put on the plant scientist, which is a botanist, coat and goggles, and go out there and look for opportunities to look into plants. You can go and read about them and write about some of the things that botanists are studying with plants. So the improving writing, the writing you could do could just be, what does a botanist do? If I like plants, let's look at a botanist. What does a botanist do? What do they study? What do they already know about plants? I could begin to make myself some notes, or I could write a summary of this. I could even compare 2 plants if you want to get into more, a deeper thing there. I could do an experiment around plants, and then I could actually write about the experiment. Well, what am I trying to discover in my experiment? What's my kind of problem or question I'm asking? What kind of experiment am I actually going to do? What am I going to change and try to observe the effects of? Where's my data? How do I analyze? So you can actually go through a whole experiment. But starting with the question, what do you want to study, is going to lead you into a specific scientific direction. And then you can instigate some more play, some investigating, some conversation about it. What's something else I have? So we could research and summarize topics. Like if we like plants, maybe there's a specific kind of plant. Maybe we like herbs, and so we want to investigate herbs. And so we research and we read about them. Maybe we read how to grow them. Maybe we live in a place where we can actually plant some. We do an experiment. We're going to add a lot of water to this one and not as much water to this one, and let's watch what happens. So you can actually do some experiments and then write about that. And scientific writing it's not a story. It's observations. It's data. It's what have I read that's going to help me design a better experiment? What is my data telling me? All of that is the kind of thinking and writing that scientists do. So we're looking at how can we bring some of that in? Well, one of them is to ask the question, what is it you want to study? And then let's explore that. So I made a list of some different types of scientists just to give you some ideas. So someone, I said before, studies plants as a botanist. Someone who studies growing plants, like how do I grow them in soil and in weather and in water and pest control and all of that, is agronomy. If I want to study tiny, tiny organisms, like the kind of bacteria that are in our gut, or the kind of viruses that make people really sick, or what's in somebody's water, the microorganisms in there, it's called microbiology. So if that intrigues them, there's that field. DNA or genes, or why is it that I look like mommy? Why is it that brother looks like daddy? That's genetics, right? So that's another thing to study. Old buried relics from human cultures. So that one's archaeology. So if any of you have watched Raiders of the Lost Ark or any of the Indiana Jones movies, he was an archaeologist. So he was studying ancient cultures, and then he'd go dig up in those areas for their relics. If you like to study prehistoric animals, so fossilized animals from years ago, then you're a paleontologist. If you like the idea of chemicals, and this is what when we see pictures of scientists, we are actually picturing a lot of times a chemist. They've got the lab coat on, they're in the lab, they got all this glassware that's boiling stuff and everything's colored, that's chemistry. If I like to study animals and animal life, that's a zoologist. The atmosphere and what we're breathing all the way up to what protects us from the sun's deathly rays, that's a meteorologist. Meteorologists also studies weather. So if I'm intrigued by like tornadoes and hurricanes, especially with some of the hurricanes we've had in the US over the last 10 years, those might be intriguing. That's a meteorologist. Life in the ocean, that's a marine biologist. Insects or bugs, that's an entomologist. And that one's actually become way more popular with a lot of the CSI shows because dead bodies, whether it's a human corpse or an animal, it tends to draw bugs. And so using those bugs to create a timeline is an entomologist. So a lot of people are more intrigued by it because now they know about it from the show. If you study rocks, you're a geologist. The relationships of living things and their environment, you're an ecologist. If you study water or intrigued by water, a hydrologist. Stars, an astronomer. Birds, an ornithologist. And the list goes on. There's so many kinds, from big picture all the way to very specific. And so depending on what your child says they're curious about or they want to study, you can begin to explore that. So, okay. So then how do we get writing out of this? Again, some of the writing is just going to be almost like notes where we're summarizing what we're reading about in terms of a topic we're intrigued by, an experiment that happened, or a kind of scientist. Okay, we might do some reading about science, and then we might summarize it. Depending on what kind of reading you're doing, you could write to some kind of prompt that's comparative or analytical in nature, like analyze this data from this experiment that they did, and what do you think this is showing? One that I did with some children, which was really fun. Yellowstone, here, just a minute, I gotta grab some water. It's kind of dry, sorry. Anyway, Yellowstone National Park, 100 years ago, I think it was just as it was becoming a national park or just before, had these big population of wolves, and they were very large wolves. And when the farmers and ranchers were all around Yellowstone and their ranches were getting attacked by these wolves, they became like high on the list to be hunted. And then it became a big sport, and they just wiped out the population of wolves in Yellowstone entirely. And so there were no wolves in Yellowstone for, I think, from like early 1900s to about 1990. And Yellowstone as a national park was starting to show signs that people just thought it was kind of the wear and tear of the park, and who knows, visitors or animal populations, whatever. But there was a big group that said, we need to bring the wolves back. They're part of the ecosystem here. They're part of the food web. They're part of the world here that keeps it all functioning. And so, of course, you had those who said, I don't want that, and those who said, I do. And so the nature group that said, let's bring them in, let's try it. We're going to do an experiment. One ounce. They brought in, I think, 2 packs of wolves from Canada. They had to do all the stuff to get them acclimated, but they did. They released them into the park. And they had all these, all were tagged so that they could track where they were and how they were, like their territories, and how they were beginning to link up and mate, and different packs that were starting to form. And they've been studying them. And I believe they brought them in 95. And they've been studying all of this for the past 20, because it's 22, 23 years now. And what they have found has been mind-blowing about the impact of those wolves on Yellowstone National Park, on the ecosystem there. Things that they never thought would happen are happening. I'm not going to tell you the details because I want you to Google it. I want you to look up Wolves Project in Yellowstone National Park, or the really great mini video they did, Wolves Changing Yellowstone, or Wolves Changing Rivers, I think, or something like that. But it was so powerful what they found. That was a study. That was a bunch of scientists realizing this ecosystem is kind of out of whack because humans intervened in a way that was necessary at the time for ranching, and then as a sport, and we kind of wiped out a population, and that actually affects things. And so it was ecologists that studied living things in the environment and said, let's bring them in. And then they've continued to study this. So now you have zoologists that are studying the animal life, and you have others that are studying the effects of these wolves on the physical environment there. And it's just all these different scientists coming together and studying all the things going on there. And it's fascinating. Now, if your child is curious about parks, or they like wolves, or they want to study an ecosystem, or you trip over this and you're like, wow, this intrigues me, let's read more. Some of the writing you may do on it is, let's create like a visualization of the food web. Like, what here is the top predator, and what do they hunt and eat, and what do these hunt and eat? So what's the balance of all of the animals here? And we're going to draw a big food web. And you can actually Google food webs images, and you'll have all of these as samples to work from. That's writing. It may be a visualization, but it's a communication from me, what I understand, out. That's writing. So maybe you create a visualization. Maybe you look at, and this is partly what we did, you look at wolf pack maps of Yellowstone from like 2000, 2001, 2002. And they actually have these in the images section. And you can compare, and you can see some of the wolf packs and how their territories expanded or diminished, or in 3 or 4 years, they're gone. So the wolves split up many times. If your alpha wolf dies, then the pack disintegrates. And so either somebody else comes in as alpha, and then it's kind of a pack change, or they kind of split up and they join other packs. They form mini packs, or there's fights to see who's going to move to alpha. There's all sorts of different behaviors. But just looking at these maps, you have some great conversation. You could even summarize, well, what happened to this pack over time? What happened to this pack over time? just by looking at these maps, I could now draw some conclusions about wolf territories and what might be going on. And that's data analysis. So there's so many different types of kind of writing that you could come out of just this wolf project. Comparing the park before and 20 years later. What's different? And how did wolves impact that? There's a prompt you could write to. Now, that all is, none of that is really a lot of data collection, but maybe you read about some of their experiments and some of the data that they did collect, and you look at, well, how would I put this into a table that would make sense? And I'm reading about, well, they released this many wolves, then they had this many wolves, and these were the dates, or these were the these got sick, this disease spread, these left. So then I could do a timeline, or I could do a data table of things. So you could take one topic, and I'm just saying the Wolf Yellowstone Project, which is reasonably new, and you could come up with all sorts of kinds of writing out of that curiosity about that. And researching that. There's not necessarily any experiments you do, but if you enjoy it, maybe you take a trip to Yellowstone. Maybe you contact some of these scientists and say, hey, we're coming to Yellowstone. We've read everything we can find about the Wolf Project and what's going on there. Can we come interview you? They learn more about it. Interviews, side note here, you can interview different scientists and write about and ask them questions about what do they do day to day, and you know, some of it's what education do you need, but I want to get into what are they studying? What are they discovering? What's their newest project? Because we don't read about their newest project. We read about scientific data that's 10, 20, 30 years old once it's been tested over and over and it's had this kind of approval, blah, 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 but not necessarily the cutting edge. So to get to go interview them and hear what's going on in this cutting edge, that's another way to kind of play scientists, go with your lab coat, interview them, and learn a little bit more about it. But I think when I drill down to playing scientist, you're doing experiments. And it doesn't have to be just mixing vinegar and baking soda. That one gets old really fast. There's so many other things that you can do. Gardening and plant life is a huge one. You can look at what different plants need. You can build it in a small space. You can observe it in a small space. You can test all the different factors that affect growth and growth rate. And then you can make data tables, and you can write analysis and summaries, and even a plan for your garden for next year based on what you did here. You could take pictures and do a garden journal. Even artistic things can come out of it. What do you want your garden to look like? Then realistically, what can we build and make? You know, what are beautiful gardens? What makes a beautiful garden? Is it smell? Is it color? Is it ambiance? Is it sound? Is it a combination of those? So we're going to be a garden scientist. We're going to go out and look at garden. So I'm saying that anything in the physical, natural world that your child is curious about or says they want to study, you can easily look at and dig into what kind of scientist would take this further. And then let's look for ways to play scientists together. Let's play scientist and actually do science together. And then let's write about it. And whether we're just writing data tables, or we're writing what we would do differently, or we're writing a summary of what a scientist like this does, or we're writing questions so we can go interview a scientist, all of these are writing opportunities that come out of science play. And science play is rooted in, I'm curious about something and I want to mix it up and I want to observe it. That's the crux of it. Don't be afraid of scientist play. I know a lot of people are like, oh, my child likes science. I don't know anything about science. You don't need to. You don't need to. There's so much you can learn right along with them. And I tell you, with the invention of Google, which I know has been around now for 15 plus years, it is so easy to find information and projects and ideas. Pinterest alone has, you could put in there like bug collections and see what comes up. And they can tell you all sorts of ways to do it. People have blogged on it. There's so much content out there around any scientific topic. You don't have to already know the stuff or be an expert. As you get into the higher levels of science, you know, if you're talking physics and chemistry at like a high school plus level, that might be a little bit more intimidating. But elementary science, middle school science, it's about what are you curious about? And let's explore that together. And let's play scientists. Let's get lab coats. Let's play scientists together. And then we're going to write about it. And we're going to talk about it all the way through. Okay? Sometimes scientists, I'm going to throw this out and then I'm going to close, but I don't know if any of you saw the movie Avatar or The Martian. Both of those are movies that come to mind off the top of my head, where scientists kept a video log. And the film itself used that video log as a way to tell us the story. But they sat in front of a video camera and they explained what they did that day or what they discovered or what they tried or what went well, what went wrong. You guys can make video logs. Lots of people go, well, videos aren't writing. They're communicating what I understand out. So in some ways it is. It's a kind of writing. It's just not handwritten words. I'm explaining what I understand or what I discovered or what I'm putting together or what I collected or what I drew or the pictures I took or what I saw over time. So they could do a video log, their own video channel or their own video, whatever, about scientists as play. Bill Nye the Science Guy, very popular show 20 plus years ago. And I think they've actually resurrected it and he's doing something else. I watched an episode and I thought it was lame. But anyway, you create your own show. Your child. I'm Jill Wolf. Should have thought about one of these ideas earlier. But I'm scientist Jill Wolf and I'm here to talk to you about woof, 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 woof. I don't know. I'm just, this is silly. But I've got my own science show and I'm going to do an experiment and I'm going to talk to my audience about what I'm doing or what I found. Or I'm going to explain to you what we did this week on Jill Wolf's Science World, or and you just create videos. You don't even have to post them. It can just be things that you keep for yourself. But excuse me, it's another way to play scientist by actually doing some science, and then doing some writing by communicating out what I understand, learned, discovered, and pondering, wonder about. And that's what we want to get to with playing scientists to improve writing. So I hope this has been helpful. If you have any questions, feel free to email me. To write in the comment section, I'll get back to you. Come join my group Homeschool Hub. The link will be in the body of this when I'm done. And you can come over there. This will also be shared there. So you can come there and make comments, ask questions, especially if you're curious about some resources for some scientist play or exploration. I'd be glad to answer those. It has been truly a joy, again, to share with you this week. And I'm going to take one last gander at my notes and make sure I covered everything. I did. Thank you guys for joining me. And I hope if you're watching this tonight, have a great Thursday. If you're watching it in the replay, have a wonderful Friday and a fabulous weekend. Talk to you guys later. Bye-bye.